I'm going to go through a little demo about constraints, how to use them, what they're used for, and to cover the different types of constraints. First off, there are multiple constraints. There is a parent constraint, orient constraint, aim, and point. There's multiple other constraints. If you go to the animation menu set, you can actually go to the constrain menu, and you're going to see parent, point, orient, scale, aim, pull vector. There's multiple constraints that you can create. I'm just going to cover a few that are quite often used in animation as well as some uses in rigging. So the first one that I wanted to talk about is parent constraint. If you go to that constraint menu, it's the very first one that shows up. So the one thing to recognize about this is there's always a driver and there's always a driven. The driver is sometimes referred as the parent or the target object. So this quite often in animation is the one object that is going to have animation. You can kind of tell right here, I have some keyframes on it. The other object is the driven or the child object. Right here we have the driven object. The driver or the parent is the one that's going to be providing the motion for the driven object. You'll see that the driven object has no keyframes. However, its translates and rotates are noted in blue. They're highlighted in blue. So when this parent object is moving, and I have it animated, it actually is moving along and it's driving, it's bringing the driven object with it. And when it rotates that driven object around its pivot point. Now you can create and change an offset. So it doesn't have to be offset, or you can move it around and change its offset from its parent, right? But when you first establish the constraint, it can be maintained. That distance from the parent object can be maintained. The next constraint is the orient constraint. And in an orient constraint, it's the rotation of the object or the orientation of the parent object will drive the driven object, or the parent is the driver. It is going to have keyframes. The driven object or the child will be driven by that object, right? You'll see that there are keyframes on the driver, and the only properties that are controlled by the parent are the rotates. So it is an orient constraint. So when it moves, when the parent object moves, the child is not driven with it. The next constraint is the aim constraint. And an aim constraint, what it's doing is when the object is moving, it's sort of a combination of the two. When the parent is actually moving, the driver, the child object is just looking at it. It's targeting it. Right? And in this one, you can see that the rotates are controlled by this object, by the parent object. So when I move the parent object, when it is moving forward, the aim constraint on the child is causing it to follow, just to kind of keep its eye on that object. Now, when the parent object rotates, it doesn't have any change to the child. You can also lock down when you define your constraint. You can determine which property is actually locked in. So I can isolate just the rotate X or the rotate Y or the rotate Z on the aim constraint. The next one is a point constraint, and a point constraint is movement. It does not obey the rotation. So in this case, the parent is moving left to right, and the child or the driven object is following along. When the parent rotates or the driver object rotates, the driven or the child does not. So that's the point constraint. To set these up, what you're going to end up doing is you select, I'm going to simulate this, you select the parent and then you shift select the child. You go to constrain, parent, you can go to the option box and choose options, and you can check the maintain offset. What maintain offset does is it keeps the distance between these set. You can also tell it which axes to pay attention to. So in this case, it's translating all and rotating all. So that would be the parent constraint. I've already set this one up, so I don't need to go and apply it again. But if I click add, it's going to close this window and apply that constraint. If I click apply, it'll apply the constraint but not close the window. So I'm just going to close that. Similarly, on the point constraint, you go to the option box. There is also a maintain offset. If you do not select that, in any case, if you choose not to maintain the offset, it will put that object right on top of the other one. But you can always change that in these offset values. It also has a constraint which axes to constrain. Similarly, Orient has similar values. It has a maintain offset and offset values and also constrain axes. So a lot of these options are quite often the same. If we go to the aim, it has more parameters considering what angle is pointing up, what is pointing at the object, and what is pointing up in the world. So those are the main constraints. And I wanted to show you an example of how you can animate constraints on and off. Especially useful in animation, where you can set up an animation where an object, I'm just going to go ahead and play this through. An object can be constrained and keyframed. So in this example, the ball has keyframes until it constrains itself to the paddle in the middle. And then the paddle holds on to it, and then the ball is actually constrained to the paddle and moving the paddle, and then it gets released. So in this case, the paddle actually does have keyframes, and then the ball also has keyframes, but it also is constrained. So what's going to happen is the translate X, Y, and Z is constrained and turned on. In this case, there are two parent blends, and these two parent blends right now are off, right? It's going to either pay attention to this parent constraint, these keyframes. Right now, this cube, this is what the paddle is off. Right now, its parent blend is set to 0. As the ball rolls forward and connects with this paddle, you'll start to see this parent blend is animated. So it sets up about right. It's set to 0. And then it's animated till it gets to 1 here and connects with the object. If I open up the graph editor, you can actually see in the graph editor at what point the blend parent is turned on and off. Here it is off, and then it comes on. It's not on fully, and then slowly is removed until it's off again, right? The same thing with this blend parent, right? This is being blended as well. So we have here, it is starting to get connected. It still has keyframes. It's moving. It's absorbing into the object. It's blending back. It's been parent constrained twice. So it's blending back to get connected, to be constrained to this side of the paddle, and then it shoots off. And that's what you can see now. It's off. In here, there it's blending between the two. It's blending between this side and the other side. And that's how that works. You blend the parent constraint. It's been constrained twice. There are two parent constraints, but it's the same. It's been constrained to the same object twice, so that one, it'll constrain to one side, be released, and slowly let it drift to the other side, and then slowly be released. That's how that's set up. Hopefully this has been helpful and informative. If you can go through and constrain different objects using parent, point, orient on your own, and even aim, you can see how those objects are affected by, the parent objects affect their child objects.